So what is the purpose of an experiment? I might want to ask a question like, for instance, does aspirin reduce the risk of heart attacks? How could I deduce the answer to that? One way is to run an experiment. Is one brand of fertilizer more effective at growing roses than another? Does the impact of fatigue on a driver's safe driving measure the same as the influence on alcohol if they've had a drink recently? These questions are often answered using randomized experiments, and what we're going to do is look at experimental design in your textbook to see different ways that this can be set up. We'll talk about, unfortunately I didn't include this in the lecture today, I didn't think we'd have time. We'll talk about blind experiments, double-blind experiments, and so on. And the purpose of that discussion is that designing those experiments properly is necessary in order to have data that is accurate and reliable for drawing conclusions. All right, I've already used a couple of these terms already, but just to make sure we're on the same page, what we're often doing with an experiment is trying to understand the relationship between two variables. When one of them causes the change in the other, or at least we're treating it that way for the purposes of our experiment, then the first variable is called the explanatory variable. You may think of that as the independent variable as well. The second variable, the one that's affected, is called the response variable, and that's the dependent variable. You can think of it as the response variable responds to the value of the explanatory variable. On the other hand, the explanatory variable explains what we end up seeing in the response variable. That's where those terms come from. Similarly, for independent and dependent, you think of the explanatory variable as independent. It stands alone. And then the response variable, it's dependent because it depends on the value we saw in the previous one. In a randomized experiment, the researcher will manipulate the values of the explanatory variable. That is, they will look at different values for this first variable and measure how those different values correspond to changes in the response variable. The measurements we observe there are how we deduce what we can conclude from that experiment. That is, if I go back to the example over here, if I have one group taking aspirin and one group not taking aspirin, I could ask, does the group taking aspirin experience fewer heart attacks, or the same number of heart attacks, or more? And looking at the differences between those groups would allow me to potentially deduce something about the impact of taking aspirin on the risk of heart attacks. All right. The different values of the explanatory variable are called treatments. So once they've controlled for those different values, each different value group is a different treatment. And an experimental unit is a single individual in the sample that we're measuring in our experiment. So in the example I just described a moment ago, the individual people taking aspirin for that study would be experimental units. All right. So I actually already undercut this a little bit. This specific example, suppose we wanted to actually test whether aspirin reduces heart attack risk, and we decide to run an experiment involving 400 men between the ages of 50 and 84, and we divide them randomly into two groups. One group takes aspirin, and the other group takes a placebo. If each person takes one pill a day for 3 years and doesn't know whether it's aspirin or a placebo, by the way, that's so the two treatments. We'll talk about that in a moment. That's called a blind experiment. The individuals in the experiment don't know which treatment group they're in. At the end of the study, researchers count the number of men in each group who've had heart attacks. Which values in the study are the population, the sample, the experimental units, the explanatory variable, the response variable, and the treatments. So let's start with population. What's the population here? Anyone have any thoughts on that?
The 400 men between 50 and 84.
Close. So remember, the population is always what we want to study, what we want to draw conclusions about.
All people at risk for heart attack?
Right. right, we basically want to talk about all people who might be at risk of a heart attack and deduce what impact taking aspirin might have on all of those people. Okay? Now, the 400 men, what are they?
The sample.
Yeah, they are the sample that we collected in the hopes of deducing information about the overall population of all people. We wouldn't really run this study just to see how it affected those 400 people. Right? That's not the purpose. The purpose isn't just to tell those 400 people whether they should take aspirin or not, and everyone else is just on their own. It's to actually decide what's going to happen for the entire population, and hopefully these 400 people will give us a good picture of what that will look like. So the population is all at-risk adults, and then the sample is the 400 that are in our particular experiment. All right, what are the experimental units?
Each person?
Right, which people though?
Each person in the study?
Right, each of the 400 people in the sample is an experimental unit. Excuse me. What is the explanatory variable here? Or the explanatory variable is the one we hope will predict the response variable.
The aspirin?
Yes, whether they're taking aspirin or not. So the aspirin is the explanatory variable. And in that case, what type of a variable is that? Here's the neat thing. It's a yes or no question, right? Taking aspirin or not taking aspirin. I could say, are you taking aspirin? And the answers would be yes, or they would be no. Those are two categories. So it's a qualitative or a categorical variable. Okay.
Categorical?
And then the response variable, what would that be? So you have to think about what is it.
Attacks?
Say again?
If they have heart attacks or not?
Right. If they had a heart attack during the course of this study. Right? That's exactly right. That's what we would measure. And that's what we would be comparing to their aspirin use. And hopefully there would be some connection. Knowing whether they took aspirin or not would affect the likelihood of a heart attack or not. And what type of a variable would that be? One where I could actually see a way to do it either way.
Categorical?
Yeah, most likely categorical, the way I described it originally. I could say, are you taking aspirin or not is the explanatory variable. And then, did you have a heart attack or not during this 3-year study? That would be the response variable. Okay. On the other hand, we could also have a count of heart attacks because you could have more than one, perhaps. And so in that case, you could think of it as a quantitative, discrete variable. But most likely the response variable is going to be categorical. And what are the treatments?
The aspirin?
Yeah. Aspirin is one treatment, placebo is the other treatment. And that's it. And so there's the brief summary of that.